Okay, we're in another section now. We're going to handle some nonlinear inequalities. We're going to restrict ourselves to this, what are quadratic inequalities. Okay, so first step, you want to factor with a 0 on one side. So you have to get that first. One side first. Okay, so factor with a 0 on one side. So get the 0 first, then you do the factor. Now this one is already factored. Okay, so that's your first step. Second, we're going to set each factor to 0. Okay, so set to 0 and solve. Okay, so I did that. Now these are what we're going to call our, we can give them a name. We can call them partition points. And we will set up a number line like this and locate those points on that number line. So here's a -4, here's a 2. Now, we know that we can't use the -4, we can't use the 2, because they would make this thing equal to 0. So they are not in the solution set. But we need to test. We will test. So this is your third step. The partition points, put them on a number line. And the fourth step you could say is, let's test between, or we'll say, well, I shouldn't say between, I'll say either side of. How about that? Test a number either side of the partition numbers. Okay, the partition numbers in the original inequality. This way, maybe you'll catch a mistake that you might have made. So now I'm going to get rid of this one here. We'll come back to this one later. So I'm going to do the testing now. I'm going to pick a point in here. I'm going to pick, say, -5. I'm going to pick something in here. 0 looks good. And I'll pick a number over here, 3. So these are my test points. Test -5, 0, 3, separately. Okay, you don't want to do them together. So let's look at our original problem here. It was written this way. X plus 4 greater than 0. So let's put in the -5. We'll see what we get. -5 plus 4. Question, is that true? Well, this is a -7. And this is a -1. That's +7. That's true. That is positive. It's greater than 0. True. Okay, so what that means is that this region over here is part of the solution set up to the 4, but not including the 4. So we're going to hold that thought for the moment, and let's test the 0 now. Okay, so this was 5, the -5. Now we're going to do the 0. Put it into this equation, this inequality, and let's check it. So we get 0 minus 2, 0 plus 4. We don't know if that's going to be true or not. -2 times 4. Uh-oh, that's a -8. That's not true. False. That means this interval in here between -4 and 2 is not included. So we will close this off with the parenthesis because the -4 is not in the set. And let's see if we pick it up over here. Chances are we're probably going to get that 3 to work for us. Let's try it. Let's try 3 minus 2 times, and I'm trying to save a little space here at the bottom. 3 minus 2 and a 3 plus 4. Is that positive? That's a 1 and that's a 7. Yes, it is positive. It's true. So that means this interval over here is also part of it. And that heads out indefinitely to the right. This one's indefinitely to the left. So you could say then your form for your solution, here's the graph of it, and then your interval form, you could write it this way, interval. Intervals looks like this, negative infinity up to the negative 4, unioned with a 2 up to infinity. So the infinity is because we're heading out to the right here indefinitely. We're heading left indefinitely, so we use a negative infinity on the left, positive infinity on the right. There's a hole in this set. It's right in here. It's not included. So we got the graph in, and that interval. The way we wrote using interval notation. So, okay, now let's see. Let's try another one here. Let's take this one here, and let's see. I'll bring that over. Let me just copy that. Let's see. Get that on the next page. So let's see what we got here. Well, I'll copy it here. Okay, there it is. Oh, that was nice. Now let's solve this one. Now it's already got the 0 on the right side, so that's good. 0 on the right. Now let's factor it. Okay. Set each factor to 0, and we'll get our so-called partition numbers. So this one's already solved. It's just x equals 0. This one step, we get a 6. So these are your partition numbers. Okay, so you'll take your number line. Here's a 0. Here's a 6. This time we're including 0 and 6. So I'm going to just emphasize that. I'm going to put a dot there and a dot there. I know that those are part of the set. We'll fix it later with our brackets. We'll put the brackets. Right now I'm not sure if they go this way or that way. I don't know yet. So let's see what we have here. So let's test now. Well, we've got, let me just indicate the test points in here. We need a test point here, here, and here. We need to test. So pick a number left of 0. How about a negative? Between 0 and 6, how about a 1? Bigger than 6, try 7. Okay, these are random as long as they fit. Just pick whatever you want. So now we got x squared minus 6x. Let's put in our numbers. We got negative 1 squared minus 6 times negative 1. True or false? 1 plus 6. Uh-oh, that's false. Okay, false. So no. That means this is not part of the solution set. Now move to the right here. Let's try 1 squared minus 6 times 1. Is that less or equal to 0? Well, that's 1 minus 6, which is negative 5. True. So you will start shading in here, and we'll take that bracket, and we'll start going this way now. So the question is, what happens here? I'm going to kind of think that it's going to stop and then come back around just right there. But let's make it official. Let's pick that 7. 7 squared minus 6 times 7. Is that less or equal to 0? Well, 49 minus 42. Nope. That's a 7. So that's false. So that means we were correct in our assumption. We're thinking it stops there. That's the end of it. So our solution then, in interval form, there's a graph of it. You can see an interval form just be from 0 to 6, right? So we can write it this way. 0 to 6. That is your solution set. Okay. So let's see. Do we have anything else here? Add something else here. No. Oh, okay, there's another one. I think, yeah, that's another problem. Okay. So, okay, we got this one, and what else did we do there? Yeah, okay, so we got that one. We're going backwards here, but that's okay. Might be able to move those pages around. I think we can actually. Yeah, okay, so let's do this one. We've got, first to get that 0, so we're gonna have to subtract that 7. Now we got this. Second, we're gonna factor. Okay, we're gonna solve. So factor this. Hopefully it's factorable, and these will be factorable. I mean, they're not gonna throw anything strange at you in these problems. So let's see, that's a negative 14, so it'd have to be a negative 7. No, let's try it again. Okay, so 2, that's negative 14. How about a negative 7, and it does work. So we'll have to have, let's see, let's do the 1 and 7. So we'll do 7 and 1 like that, make that a negative positive. There it is. Okay, and that's less than 0. Okay, so we then set these to 0 and solve. That's a 2, and then over here we got an x plus 1 is 0. So these are, remember I call these the partition numbers. Let's set up our interval up here. It looks like we have a negative 1 and a 7 over 2. Okay, so let's pick some test numbers here. Let's try something over here. How about a negative 2? And over here we can use a 0. And over here, this is 3.5, so let's try a 4. So let's do the testing now. Now notice it's strict inequality, so we will not be using the negative 1 or the 7/2. They're not in the sets for sure. But let's go ahead and test the negative 2. Got 2 times negative 2 squared minus 5 times negative 2 is, we can work with this second one here if you prefer. In other words, we'll minus that 7 and just work with that. I mean, we're pretty careful. That's the same inequality. There's nothing wrong with that. So what do we have here? Let's see, 4, that's an 8 plus 10 minus 7. Is that less than 0? No. 18 minus 7 is 11. False. So it's not over here. Let's try the next one. Let's try the 0. So we'll have 2 times 0 squared minus 5 times 0. Is that less than 7? Well, let's see. I went back with the 7. Or that's okay. So I switched back to this one by accident. We can still use it. This is 0. That's true. Okay, 0 is less than 7. So we're picking up some solutions in here. And it will be this way because we started there and we're going to the right. And we're probably going to stop here. That seems to be the pattern of these. But let's check it anyway. So we got a 2 times a 7 over 2 squared minus 5 times 7 over 2. And again, I'll go back to that minus 7. I can still use that. So I got 2 times 49 over 4 minus 35 over 2 minus 7. So we got a little work here. This cancels, we got a 2. So 49 minus 35 is what, 9? And 5 is 14 halves minus 7. Oh, I'm sorry. I'm testing 7 halves. I shouldn't be testing that. I already know that. So it's my accident there. I wasn't thinking straight. I was distracted or something. So I got to test the 4. So forget this. Okay, let's try the 4. test the 4. So I have 2 times 4 squared minus, okay, so then we have to take, let's see, I got 4 squared minus 5 times 4, and then minus 7. Is that less than 0? Well, it's 2 times 16 is 32, minus 20, minus 7 is less than 0. So that means we have, let's see, 32 minus 27 is 5. True or false? That's false. Okay, so come back up here. We did cut it off right there. And we can now read our solution as -1 to 7/2. That is our solution. And that's good enough for right now. We'll see some context for this in the next section, but for right now, we're good.